Okay, so this is for geometry for 1-4, and what we're looking at is angle measure. So what you need to be able to do by the time we're done is know and apply properties of angles to solve problems. So let's take a look at what we're talking about. Two kind of things to know about. A ray is a part of a line with one endpoint that extends indefinitely in one direction. So kind of the symbolic representation would be two letters, and then you'd have one arrow above it that would show which way it's going. So you'd have ray RA looking like that. Okay, so if I wanted to draw ray X at XW, that's going to look like this. From here, X to W. Or if I wanted S going through T, it would look like this. All right, an angle is going to look a little bit different. Angle says it's formed by two non-collinear rays that meet at a common point called the vertex. So the symbolic representation is going to look like this. So if I had an angle ACB, that's what that's going to look like. So if I've got ACB, that means it's going from C through A, and then from C through B. So what you're looking at is angle ACB coming through here, angle CB coming through, ray CB coming through here. Another way to say that would be to say BCA. Both of those would work. So that's what you're talking about when you look about an angle. So an angle divides a plane into three distinct parts. Points angle CBD lie on the angle. A lies on the exterior of the angle. E lies on the interior of the angle. This is because, of course, if this indicates that it keeps going. E is going to be on the inside, A is going to be on the outside. There's no point where A ever comes inside of that angle. All right, name a point on the exterior of DEB. Well, DEB is talking about this angle right here. So a point on the exterior of that would either be, I would say either G or F. That is what exterior means. So I'll name all the angles that have B as a vertex. Well, there's quite a few of them. In fact, there's 4 of them. So all the angles that have B as a vertex should look like this. You should have angle ABG. That's this one right here. You should have angle 7, angle 6, and angle 5. So you should have 1, 2, 3, 4 angles that all fit into that. Name the sides of angle 5. Angle 5 is right here. So what two rays create that angle? Well, you're looking at ray BG and you're looking at ray BE. That's what you're looking for. So what's another name for angle 7? Well, angle 7 is right here. So another name for that would be either ABD or angle DBA. That's what you're looking at for those two. All right, so when you're classifying angles, classify angles by how big they are. All right, so when you're looking at angles, that's kind of what you're looking at. So if it's got this, that tells you that it's going to be a right angle. Okay, and what that means to be right is that means it is exactly 90 degrees. Exactly 90 degrees. It's only 90 degrees. It never changes from there. This is quite obviously less than 90 degrees, so we call that acute. And basically what that means is that it goes from 0 to 89.9 degrees. That is going to be your measure there. This is quite obviously bigger, so it's going to be obtuse. Obtuse is going to go anywhere from bigger than 90 up to 180. Okay, so it's going to be from 90 to 180, basically like 90.1 up to 180. All right, but not quite equal to 180. So maybe we'll write this as an inequality. 90 is less than the angle, which is less than 180. Notice I didn't put the equal sign in there because that means that it can't be 90. It's just going to be bigger than 90 or smaller than 180. This last type, you notice how it's just a straight line? Well, that's what we call it. We call it a straight angle. and that's going to be exactly 180 degrees. So those are your big kind of ways to classify angles. So if we take a look, this is a whole bunch of angles all mixed into one thing. Classify SYT as acute, right, or obtuse. Well, if I look at SYT, that to me does not jump out as even close to 90 or anywhere near it, so I'm going to go with acute. Classify SYX as acute, right, or obtuse. Well, if I look at SYX, that is clearly bigger than 90, but I can't tell anything else about it. So obtuse is the best definition there. So an angle bisector is exactly what it sounds like. Bisector means cut exactly in half. So that means that is a ray that splits the other two in half. It's often indicated by these things. These things say this angle is equal to is congruent to this angle. That's how they tell you that. So if you look, KN bisects JKL. So KN bisects JKL. That's here, that's here. So that means these two are equal to each other. JKN is 8x minus 13. I'm talking about the angle measure now. NKL is 6x plus 11. Find JKN. So find this whole big angle. Well, first thing I do is figure out what x is. So 8x minus 13 equals 6x plus 11. So a little solving. Why am I minusing 2x? I don't know what I was thinking there. Let's do this the right way. Da, da, da. You should end up with 2x. You should add 13 over. So 2x equals 24. X equals 12. Just like you've always studied. X equals 12. So how big is this thing? Well, 6 times 12 is going to be 72 plus 11 means this is 83. This is also 83 because it's congruent. So together that angle is going to be 166 degrees. So let's draw a picture for this one since they don't give one. QS bisects angle PQT. So let's draw angle PQT. It's just a sketch. We're not locked into anything here. QT and QS bisects it. So this bisects. So this one's equal to this one. PQT is 6x plus 4. TQS is 7x minus 2. So figure out what PQT is. So figure out what the whole big angle is. That's what they're looking for. So 6x plus 4 equals 7x minus 2. So a little subtraction. I get x equals 6. So you can verify that yes or no. So this is going to be 7 times 6 minus 2. This bottom one's going to be 7x. 7 times 6 minus 2, so that's going to be 40. Top one is 6 times 6 plus 4, that's also 40. So the whole thing together is going to be 80 degrees. That's all I got. That's a short section. So take a look at that, kind of know that by heart and know that into your fingertips.